Welcome back to my YouTube channel. In this video, we will see derivatives of functions in parametric forms. They will ask one 3 marks question on derivative of a function in parametric forms. See the definition. X and y are given as functions of a single variable, that is x equal to f of t and y equal to g of t, or two functions and t is a variable. See, we have two functions here, x equal to f of t and y equal to g of t are any two functions in terms of a variable t, and these two are called parametric functions or parametric equations. See, x equal to f of t and y equal to g of t are called parametric functions or parametric equations, and t is called parameter. So, t is a parameter here. So, just to remember, x equal to f of t and y equal to g of t are any two functions in terms of t. X and y are called parametric functions or parametric equations, and t is the variable, it is called parameter. Therefore, we can write dy by dx as, that is the value of dy by dx equal to dy by dt divided by dx by dt. So, this is very important. While finding the value of dy by dx, we are using this formula, that is dy by dx equal to dy by dt divided by dx by dt. Right? So, now we are having some examples related to derivative of functions in parametric forms. See the example. Find dy by dx if x equal to a inside bracket theta minus sin theta and y equal to a inside bracket 1 minus cos theta. So, this is a very important example. They will ask it for 3 marks. See, yes, in this problem, theta is the parameter. See the values of x and y. The values of x and y, they are given in terms of theta. See the value of x. X is equal to inside bracket theta minus sin theta. So, theta is a variable here. So, theta is the parameter here. And y equal to, we are having a into a inside bracket 1 minus cos theta. So, theta is a variable and we are calling theta as the parameter here. So, I go for solution of this. A solution. I will write as given. Yes, first I will write the value of x. See the value of x equal to, we are having a inside bracket theta minus sin theta. We differentiate this with respect to theta. So, why you are taking with respect to theta? Derivative of x with respect to theta we are taking. So, why you are taking derivative of x with respect to theta means because theta is the parameter here. Right? So, therefore, I will write dx divided by d theta is equal to a constant. You write outside. The derivative of theta with respect to theta is 1. Derivative of theta with respect to theta is 1 minus you write as it is. Derivative of sin theta. So, derivative of sin theta is cos theta. So, this is the value of dx by d theta. Next, go for the value of y, and I will write the value of y equal to, the value of y equal to a inside bracket 1 minus cos theta it is. Now, you find the derivative of this, you find dy by d theta. So, therefore, I will write dy by d theta is equal to a differential of 1 with respect to theta is 0, because 1 is constant, its derivative is 0, minus you write as it is, this minus you write as it is. You already know derivative of cos theta with respect to theta. So, derivative of cos theta with respect to theta is minus sin theta, and after that we are having derivative of theta with respect to theta, its value is 1. So, therefore, I will write dy by d theta is equal to a as it is. Next, see 0 minus inside bracket minus sin theta. See, we are having minus into minus plus. Minus into minus is plus, plus sin theta plus 0. Plus sin theta plus 0, it is a sin theta, and sin theta into a is we are having a sin theta. This is the value of dy by d theta. So, now I want the value of dy by dx. So dy by dx equal to, we are having dy by d theta divided by you write dx divided by d theta. dy by d theta divided by you write dx by d theta. So therefore I'll write the value of dy by dx. So therefore I'll write the value of dy by dx is equal to see the value of dy by dx. So dy by dx equal to, we are having dy by d theta divided by dx by d theta. And see, already we have the value of dy by d theta is a sin theta. So you write a sin theta. Next divided by dx by d theta. Dx by d theta is a inside bracket 1 minus cos theta. A inside bracket it is 1 minus cos theta. This a get cancelled. A get cancelled. So therefore I will write dy by dx is equal to sin theta. So half angle formula I have to use. We are having the formula of sin theta. Sin theta is what? 2 sin theta by 2 into cos theta by 2. See the formula of sin theta. The formula of sin theta is 2 sin theta by 2 into cos theta by 2. And next one, we are having the value of 1 minus cos theta. See the value of 1 minus cos theta is 2 sin square theta by 2. This is very important. Remember the formula. See the formula of 1 minus cos theta is 2 sin square theta by 2. 1 minus cos theta is what? 2 sin square theta by 2. And remember the formula of 1 plus cos theta is 2 cos square theta by 2. So these two formulas are very important. You remember, right? So remember these two formulas. So one is we are having yes 1 minus cos theta. The value of 1 minus cos theta is 2 sin square theta by 2. Next one, we are having 1 plus cos theta. And the value of 1 plus cos theta is 2 cos square theta by 2. And here in place of 1 minus cos theta, I am using 2 sin square theta by 2. So now 2 get cancelled. Next, this sin theta by 2 and 1 sin theta by 2 form sin square theta by 2 get cancelled. So therefore I will write dy by dx. dy by dx is equal to cos theta by 2 divided by sin theta by 2. Cos theta by 2 divided by sin theta by 2. It is a cot theta by 2. It is a cot theta by 2. See, cos theta by 2 divided by sin theta by 2. It is a cot theta by 2. So therefore the value of dy by dx is equal to cot theta by 2. Right? So this is the very important example. Simple we are having. Next one, I go for second example. You pause the video and take this one. The second example I go. If x equal to a sec of cube theta and y is equal to a tan cube theta, find dy by dx, at theta is equal to pi by 3. Find dy by dx at theta equal to yes pi by 3. Listen, very important example it is. See what they are given. The values of x and y they are given. See x equal to, we are having a sec of cube theta, y equal to a tan cube theta. See in these two, theta is the parameter and you should find the value of dy by dx at theta equal to pi by 3. So I go for solution of this. So first I will write given values. See we are having x equal to what? A sec of cube theta. You differentiate this with respect to theta. So why we are finding a derivative of x with respect to theta means because theta is the parameter here. See, x is in terms of variable theta. X is what? In terms of variable theta, and theta is the parameter. So therefore, you find the differential of x with respect to theta, dx by d theta is equal to a constant. You write outside. Next, you go for derivative of sec of cube theta. You go for a derivative of sec of cube theta. So see, sec of cube theta. Use a chain rule. First you differentiate the power, and afterwards sec theta, and finally you differentiate theta with respect to theta. So now see, derivative of sec of cube theta. Derivative of sec of cube theta is 3 into sec of raised to 3 minus 1 sec of square theta. Alright, I am using the differential of x raised to n formula. We are having a differential of x raised to n is equal to n into x raised to n minus 1. That formula I am using. That is derivative of sec of cube theta is 3 sec of raised to 3 minus 1 theta. So 3 minus 1 means 2. And after that you find the derivative of sec theta. So derivative of sec theta is sec theta into tan theta. Derivative of sec theta is sec theta into tan theta. And finally we are having derivative of theta with respect to theta. Its value is 1. So therefore I will write the value of dx by d theta. Dx by d theta is equal to 3 into a 3a sec of square theta into sec theta. It is a sec of cube theta, and after that you write into tan theta. So this is the value of dx by d theta. Next you go for the value of y. See, the value of y is equal to, we are having, so y is equal to a into tan cube theta. Y equal to a into tan cube theta. So now you differentiate this y with respect to theta. So therefore I will write dy by d theta is equal to, dy by d theta is equal to a constant. You write outside. Next one, a derivative of tan cube theta. So derivative of tan cube theta, derivative of tan cube theta, I will write 3 into tan square theta. 3 into tan square theta. See, first you differentiate the power, and after that you differentiate the term, that is tan theta. So first I differentiated the power tan cube theta. Power tan cube theta will becomes 3 tan square theta. And next one, derivative of tan theta. So see, derivative of tan theta is sec of square theta. Sec of square theta. And after that we are having a derivative of theta with respect to theta. Its value is 1. So therefore I will write dy by d theta is equal to 3 into a 3a. 3 into a 3a. Next you write tan square theta and into sec of square theta you write. So therefore I will write dy by dx is equal to, dy by dx is equal to, you write dy by d theta divided by dx by d theta. It is the formula. Alright. So dy by d theta already have. See, this is the value of dy by d theta. So dy by d theta is 3a into tan square theta into, you write, sec of square theta divided by dx by d theta. Dx by d theta. So dx by d theta is 3a. Next sec of cube theta. Sec of cube theta into, yes, tan theta. Into tan theta. This 3a get cancelled. Alright. So next sec of square theta and 1 sec of square theta form sec of cube theta get cancelled. Tan theta, 1 tan theta form tan square theta get cancelled. So therefore I will write here the value of yes, dy by dx. So therefore I will write dy by dx is equal to, see, tan theta and 1 tan theta form tan square theta get cancelled. So tan theta remains in numerator. Sec of square theta and 1 sec of square theta form sec of cube theta get cancelled. So divide by sec theta remains. So now this is equal to tan theta. So tan theta is what? Sin theta by cos theta, and into, see, this tan theta written sin theta by cos theta. And next one, we are having a divided by sec theta. So divided by sec theta means what it is? 1 by sec theta, and 1 by sec theta means it is a cos theta, right? this cos theta get cancelled. So therefore we are having the value of dy by dx is equal to sin theta. Dy by dx equal to sin theta, but we required dy by dx at theta equal to pi by 3. So therefore you write dy by dx at theta is equal to pi by 3 is equal to sin theta. We are having in place of theta you take pi by 3. So it is sin pi by 3. Sin pi by 3 means what it is? Sin 60. So pi means 180. 180 by 3 it is 60. Sin 60 and the value of sin 60 is root 3 by 2. It is root 3 by 2. So therefore dy by dx at theta equal to pi by 3 is root 3 by 2. Right? You remember, this is the very important simple examples we are having on parametric forms. So next example I go. Third one. Let y equal to x cube minus 8x plus 7 and x equal to f of t, x equal to f of t if dy by dx, sorry, dy by dt is equal to 2 and x equal to 3 at t equal to 0, then find the value of dx by dt at t equal to 0. At t equal to 0. So this is the very important example. They will ask it for Karnataka CET. Very important for CET. So what they are given? The value of y equal to x cube minus 8x plus 7 and x equal to f of t. If dy by dt equal to 2 they are given and x equal to 3 at t equal to 0, then find the value of dx by dt at t equal to 0. Right? You should find the value of dx by dt at t equal to 0. So see, I go for a solution of this. You know already we have dy by dx is equal to dy by dt divided by dx by dt. So why I written here dy by dx equal to dy by dt divided by dx by dt means, see, x is equal to f of t. It is in the parameter t. X is what? In the variable t, and they are given the value of dy by dt is 2. Dy by dt is 2. Required to find the value of dx by dt at t equal to 0. Right? So hence I took here dy by dx equal to dy by dt divided by dx by dt. So now dy by dx means we have the value of y, and by taking the value of y equal to x cube minus 8x plus 7 you find the dy by dx. Right? So dy by dx means the differential of x cube minus 8x plus 7 with respect to x is equal to dy by dt, already given in the problem. So dy by dt is 2 divided by dx by dt, we don't know. It is required to find, hence you write dx by dt as it is. Dx by dt you write as it is. So therefore I will write derivative of x cube. So derivative of x cube is 3x square. So derivative of x cube is what? 3x square minus a derivative of 8x. A derivative of 8x is 8. See, derivative of x cube is 3x square minus derivative of 8x. Derivative of 8x is minus 8 plus derivative of 7. So derivative of constant 7 is 0. Derivative of constant 7 is 0 is equal to 2 divided by dx by dt, you write dx by dt, you write. So now, yes, at t equal to 0 you find, at t equal to 0, at t equal to 0 you find dx by dt. At t equal to 0, we have at t equal to 0, the value of x is c, they are given. At t equal to 0, the value of x is 3. And you take the value of x equal to 3 in this one. You take the value of x equal to 3 in this one. So therefore, I will write 3 into 3 square. Because x is 3 minus 8, you write e is equal to 2 divided by dx by dt, you write. So therefore, yes, 3 square 9, 9 3 that 27, 27 minus 8 is 19. Alright, see, 3 square 9, 9 3 that 27, 27 minus 8 is 19. 19 is equal to 2 divided by dx by dt. 2 divided by dx by dt. So therefore, I will write 19 into dx by dt is equal to 2. So therefore, dx by dt is equal to yes, 2 divided by 19. So very simple example it is. Dx by dt is equal to 2 by 19. Right? So next I go for another example. Fourth example. You see, this is the very important. It is important for CET and as well as for your theory exam. This example is very important for theory as well as CET. See the example. Find dy by dx. Find dy by dx if x is equal to a inside a bracket cos t plus log of tan t by 2. Tan t by 2. Y equal to a sin t. Y equal to a sin t. See, we find the value of dy by dx if x equal to a inside bracket cos t plus log tan t by 2 and y equal to a sin t. So I go for solution of this. I will write given values. First I will write the value of x. X equal to a inside bracket cos t plus log of tan t by 2. Log of tan t by 2. See, t is the parameter here. T is the parameter. See both the values of x and y. See these two values x and y are in terms of t. Are in terms of a parameter t. T is the variable here. So therefore, you differentiate this. Differential of x with respect to t you go. Differential of x with respect to t. So see a constant. Differential of cos t. A constant you write outside. Differential of cos t minus sin t. Very important. Differential of cos t is minus sin t. Differential of log tan t by 2. For this you have to apply chain rule. You apply chain rule for this. Differential of log tan t by 2, differential of log x, it is 1 by x, and in place of x what we are having tan t by 2. So it is 1 divided by tan t by 2. 1 divided by tan t by 2. Next you differentiate tan theta. You differentiate tan t by 2. Differential of tan t by 2. Differential of tan theta is sec of square theta, that is sec of square t by 2. First you differentiate log x. It is 1 by x. In place of x, what we are having? Tan t by 2. Next, we differentiate x. So, x is what? Tan t by 2. Hence, derivative of tan t by 2 is sec of square t by 2. Next, you differentiate t by 2. So, t by 2 derivative, it is 1 by 2. Derivative of t by 2 with respect to t is 1 by 2. So, now, therefore, I will write the value of dx by dt is equal to a minus sin t you write as it is plus 1 by tan t by 2 and this is 1 by 2. 1 by 2 is constant, you keep outside, you keep outside, it is You keep it outside. Next one, tan t by 2. Tan t by 2. 1 divided by tan t by 2. 1 divided by tan t by 2. It is a cot t by 2. Cot t by 2. Alright. And into sec of square t by 2. You write. Sec of square t by 2. So therefore, yes. Therefore, you write. For this, you have to put square bracket. Here also you put square bracket. So now, this is equal to A as it is, minus sin t plus 1 by 2 cot t by 2. Cot t by 2. See the value of cot t by 2. It is a cot t by 2 is a cos t by 2 divided by sin t by 2. Sin t by 2 into sec of square t by 2. Sec of square t by 2 is a 1 by cos square t by 2 because sec of square theta is 1 by cos square theta. So now, therefore, I will write dx by dt is equal to, see the value of dx by dt. The value of dx by dt. Dx by dt is equal to, yes, A you write as it is. Next you write minus sin t as it is. Minus sin t as it is. See, this cos t by 2 and 1 cos t by 2 from cos square t by 2 get cancelled. See, cos t by 2 and 1 cos t by 2 from cos square t by 2 get cancelled. So, you will get 1 by 2. 1 by 2. Next, yes, in denominator we get sin t by 2 into cos t by 2. Yes, bracket complete. So, therefore, dx by dt, I am sorry, dx by dt is equal to A inside bracket minus sin t, half angle formula I have to use. That is 1 by 2 sin theta by 2 into cos theta by 2. It is a 1 by sin t because we are having the formula. Sin theta is 2 sin theta by 2 into cos theta by 2. So, 2 sin theta by 2 into cos theta by 2 is sin theta. But in place of theta, what we are having t. So, hence I written sin t. And it is a minus sin t by 1. So, therefore, I will write dx by dt is equal to, dx by dt is equal to A as it is. Now, you go for cross multiplication. Sin t into minus sin t. It is the minus sin square t plus 1 on the 1 divided by 1 into sin t. It is a sin t. Now, this is equal to A as it is. 1 minus sin square t. See, 1 minus sin square t. 1 minus sin square t is what? Cos square t. Minus sin square t plus 1. That is 1 minus sin square t is a cos square t. So, you write A into cos square t divided by sin t. Divided by sin t. So, this is the value of dx by dt. Next, you go for the value of dy by dt by taking the value of y equal to A sin t, y equal to A sin t. So, see, and I will write, and the value of y I will take. So, y equal to we are having A sin t, y equal to A sin t. You find the derivative of this dy by dt. Dy by dt is A constant. Derivative of sin t with respect to t is a cos t. Derivative of sin t with respect to t is cos t. So, therefore, I will write as dy by dx is equal to dy by dt divided by dx by dt. So, now dy by dt you have dy by dt is A cos t. A cos t divided by 1 it is. Dx by dt is what? A cos square t divided by sin t. So, now, yes, this is equal to A cos t divided by 1 you write as it is. Remove this division and write into, so you will get the sin t divided by A cos square t. This A get cancelled, cos t and 1 cos t get cancelled. So, now this is equal to, it is sin t divided by cos t. Sin t divided by cos t is tan t. Tan t. So, therefore, the value of dy by dx is tan t. Right? A very important example, you remember. Next one, I go for another example. So this example is very important. It is a fifth example. So pause the video and take these all. So these all things are very important. Example, fifth example it is. If x is equal to square root of a sin inverse a raised to sin inverse t, y equal to square root of a raised to cos inverse t, then show that dy by dx is equal to minus y divided by x. Then show that dy by dx is equal to minus y by x. Very important example. Simple and important. See, I'll use the easiest method to solve this example. See, you take the product of x and y. I will take a product of x and y. So product of x and y is equal to square root of a raised to sin inverse t into square root of a raised to cos inverse t. A raised to cos inverse t. So simple method I am using. Otherwise, if you want to differentiate x with respect to t by applying as derivative of square root of x formula, and yes, afterwards you find dy by dt by applying square root of x formula, that is c. It becomes very lengthy. That derivative of square root of x and afterwards terms which lies inside the root. Right, so it becomes a very long procedure. So instead of doing that, I am using a very simple method for this one. Just I am taking the product of x and y. So therefore, I will write xy is equal to, this is what, square root of p, and this is square root of p. So you are having square root of p into square root of p. So square root of p into square root of p is square root of ab. Square root of p into square root of b is what? Square root of ab we are having. Square root of p into square root of b is square root of ab. Square root of ab it is. So now see, xy is equal to, yes, I will write square root of a raised to sin inverse t into a raised to cos inverse t. A raised to cos inverse t. After this, therefore you write xy is equal to, see, yes, root you write as it is. See, here also you are having base a and here also base a. When bases are same, have to add the powers and you will get a raised to sin inverse t plus cos inverse t. A raised to sin inverse t into a raised to cos inverse t. It is a raised to sin inverse t plus cos inverse t. So therefore xy equal to, I will write square root of a raised to. We are having the properties of inverse trigonometric functions. The properties of inverse trigonometric function is a sin inverse t plus cos inverse t. See, the value of sin inverse t plus cos inverse t. Sin inverse t plus cos inverse t is a pi by 2. It is a pi by 2. We are having the properties of inverse trigonometric functions. The value of sin inverse t plus cos inverse t is a pi by 2. So xy equal to, we are having square root of a raised to pi by 2. Now you differentiate this. And for this you have to apply product rule. You apply product rule. So see, I will apply product rule for this. X outside, a derivative of y. So derivative of y is dy by dx. Plus y outside, derivative of x with respect to x. Differential of u formula I am using. U outside, derivative of u with respect to x plus v outside, derivative of u with respect to x. And is equal to, see, a is constant, pi by 2 is constant. See, a is constant, pi by 2 is constant, a raised to pi by 2 is constant, and square root of a raised to pi by 2 is constant. So this whole term is constant. This whole term is constant, and derivative of this constant term is what? 0. We already know derivative of constant is 0. So therefore I will write x into dy by dx plus y into dx by dx, it is 1 is equal to 0. So therefore I will write x into dy by dx plus y into 1 is y is equal to 0. So therefore I will write x into dy by dx is equal to plus y taken this side, it becomes minus y. It becomes minus y. So therefore I will write the value of dy by dx is equal to minus y as it is, and to take x in this side, you will get divided by x. So this is the required proof. Dy by dx is equal to minus y by x. Alright. So these 5 examples are very important for your theory exam and as well as for CET. So remember these all things. So kindly share, subscribe my channel. Thank you for watching.